Hello, this is Mr. Michael, professor in Aksum University, Ethiopia. Today we're going to talk about the next topic, and this is entitled Programming with MATLAB. Um, last topic we talked about the MATLAB fundamentals, how to do the basic calculations in MATLAB, what are the syntax, basic syntax, and some basic functions also. Right now, we will move on to programming with MATLAB because these are the most important topic in the course because, like I said, we need to make a program and we will do it in MATLAB. We will see also what are the things that we need to understand and the things that are of the same somewhat spirit in the other programming languages such as C++, Java, whatever. And you will see also how MATLAB is robust and how it's quite more powerful than this general programming languages and why it is really devoted for technical computing. So I have here, by the way, I open up my MATLAB here, okay, and open it this up, and then as we move the topic, we will make something here, okay. So this is the title of programming with MATLAB. We have several objectives here. I will just try to read some of this. So the first objective is learning how to create well-documented M files in the edit window and invoke them in the command window. We will do that. Next is how script and function files differ. We will talk about some how do we write the scripts and a much better way to make a program is to make a function. We will do that. Another thing here is how to incorporate help comments in functions. Okay, somewhat the same in the other programming languages, and set up M files so that they interactively prompt users for information and display results in the command window. Understanding the role of sub-functions and how they are accessed. Knowing how to create and retrieve data files. Several objectives really. So many talking here. Learning how to write clear and well-documented M files by employing structured programming constructs to implement logic and repetition. Recognizing the difference between if, else if, and switch constructs. Recognizing the difference between for, and while structures. Okay, what are these things? What is meant by vectorization and why do we need this one? MATLAB animation, we will try to do this, but not so very important in the course. This is much advanced actually. And how to write anonymous functions. This is quite important for all of us. To pass functions to function endpoints. We will talk about this as we move on. So an M file, so any programming, any executable, or not really executable, but any script or something like a program that you will write in MATLAB, it has a .m file, so we call it M files, and it allows you to put commands in text files called this is what I'm saying, M files with .m extension. Okay. Sometimes in the command windows, if you remember, we try to write a program in the command window immediately, like this, for example, in the command window, 4 plus 3, answer is 7. This is a direct execution, but just like in C, C++, Java, sometimes we really have to make a program in a file, maybe in a notepad like this. Although they have difference because MATLAB is this is interpreted language, C++ is compiled language, but somewhat we will not discuss more about that. Okay, the difference. Okay. Now there are two main kinds of M file. First one is the scripts, like I said, and the functions. Okay, what are the difference between the two? I will show you. So script files. A script file is merely a set of MATLAB commands. Okay, you do the reading here. Okay, so when MATLAB runs a script file, it is as if you type the characters stored in the file in the command window. That's correct. So what I'm saying here is, let's have an example here. If you want to make so much things to do here, but let us make, let's say, I will, we can make a script file by, you have seen this one here, new script, you can click that one, or you can also edit here. You write edit, and then your Michael, for example, the name of the script, Michael, let's say Michael, something like that. You can do that, or you can click new script, and then it will pop up. Doesn't, it's up to you. So let's hit enter, and then MATLAB, the Michael.m does not exist. Do you want to create it? Okay, so say yes. And then here, let's just write a very simple command, like you are in command window, a is equal to 4, and then you put here a semicolon, meaning it will not, the meaning here of a semicolon is it will not be echoed in the command window. So you will see the difference later as we move on. And then let's say b is equal to 4 plus 3, for instance, and then a, b. So what I'm saying here, if I will say a and b with no semicolon, I am asking, I'm telling the, what is this? I'm telling this script file to echo the value of a and b in the command window. So by the way, so from here you can save it immediately here, or automatically MATLAB, once you click in the command window, right now we are in editor window, once you click here, automatically, you see this one, before it was blue, but now it's gray. Look at, let's write something here. Let's say C. This one is blue, but we don't need C actually, we will erase that. This one is blue, it's not, meaning it's not saved. When you click here, it's gray now, it means it's saved immediately. So to invoke the script file, simply write here Michael, and we expect that when you hit enter, okay, it will give you, let's move this one a little bit, like this, a is equal to 4 and b is equal to 7. That's what I'm talking about. Okay, so this is a simple script file. So if you want to run, like I said, you write Michael, or you can click run here. You can do that. Now, function files, this is somewhat more advanced, though it's quite easy to understand really as you practice. It's a little different purpose from script files because it can accept input arguments, and also it can return outputs to the command window. Okay, but the variables that are created with is only within the function, and it does not echo in the command window. For example, this is a script file. We input here a, b. Look at in the workspace, we have a, we have b, and then the and 7. Now, if you are making a function, the variable will be only local. It's a local variable actually, only in the function. It will not be saved in the workspace. It will be automatically erased once it is finished. So I will show you as we move on. Okay. So file syntax, let me see. So the general syntax for a function is something like this. Function out var is equal to func name, and then that argument list. Okay. And then you have this help comments, statements, out var is equal to value. So what's the meaning of this? Out var is actually the output variable name. If you want the output of a certain function, which will, I do not know, maybe it will compute an area of the circle. It will compute the salary or payment, something like this. So it will output that one. We will see. We will make an example later. The func name, that is the function name. Okay. So when you make the function, when you write later edit, as like what I do a while ago, edit Michael, you write edit and then the name of the function. The name of the function should be also the name of the file. By the way, arglist is the input argument list. It could be several argument lists, could be thousands. I think around, I'm not so sure, around maybe less than 10 probably. I'm not so sure about the maximum number of argument lists. And you can pass it into the function, and in the help comments, which will help you. It started with that percentage, what is this, a symbol, It's just a help comment, meaning to say that when you call that one, when you call the function, that one will just guide you what is the functions all about, but it will not be executed in the program. And the statements, MATLAB commands for the function. Okay, so whatever they will do, it will solve something, it will compute, it will make a for loop or whatever it is. That is a statement. Okay, so let's have here maybe we can have a simple example before we proceed. Let's have a simple function here. Let's say look at this workspace here. Okay, let's say I will write here edit, and then I will say my name is myfunc, or let's say my function is better. Okay, so the name of my function is my function. Okay, enter, and then you add this one. Okay, here we go. This is my function, and then I will make a simple function which will compute the area of the circle. So function area circle. So that's my output. My function, let's say radius. Okay, like that. So radius is the input argument list. My function is the name. Area circle is the output variable. Yeah, and then this is it. And then after that, let's say area circle, I think you know the equation, that's pi r squared. So you call the pi, the default function, pi times radius, and then squared. That's it. Radius, no need for that here, no need to do that because this is simply a scalar, so you just use this one. And then the function, sometimes you can put n here in the what is this, in the file, I mean in the PowerPoint, no n there, so it's just fine. No need, you can also erase this one. But if there are so many functions inside your function itself, if you are calling sub functions, then you have to put an n here because the MATLAB might be confused. Where is the ending of the function? Where does it start? Somewhat. So the easiest, maybe I could say, for you so that you will not be confused, when you make a function, there should be an n at the end. It will be better. So this is it. This is below file. I will enter here, and this is gray. It means it's safe. Okay. So when you call the function, you can say you make a variable. Let's say a. Let's say or whatever. Mike is equal to, call the name of the function, my function, and then you input the argument list. For example, I need a 3. Okay, for instance, 3. So you are calling the function, my function, and then you are sending an input argument 3. So if you look at the function here, 3 is radius. It will go inside the function, it will compute area circle, it will compute radius squared, 3 squared, that's 9, 9 times pi, 3.14, around 27, 28 something. And it will store that value in the area circle, and then the function will the output argument of the function, it will return the area circle, and it will store that to the variable Mike. So let's do that. Let's hit enter. Oh, not assign. Let me see. What was? Maybe I made a mistake here. Ah, okay. I made a mistake. Circle, and this is circle. So the computer is confused. Circle. Okay. Okay. So let's do it again. I hit up arrow, by the way. Okay, here. So my function 3, input 3, the output is 28.2743. That is the area of the circle. You can check it by yourselves. Now look at this one. The radius is 3, area circle is 28.2743, but the radius here is not included in the workspace because it's immediately, that is a local variable. It's not stored in the workspace. It will be erased automatically once the function has been finished. Okay, so that's the function. Alright, sub functions, like I said, sometimes you want to put in reality, when your program will become more complicated, there will be many functions inside a function, and we call it sub-functions. So that, like I said, there's a primary function and one or more sub-functions. The primary function is whatever function is listed first in the M file. Okay, its function name should be the same as the file name, like in C++ or C we have end main, okay, or void main. So if you remember that one, that is the main function, and then at the bottom of that main function there are several functions, and then you call them as sub functions depending on the procedure or the output of this function, or what will it do. Then you name the function in some sense, something like compute equation, sub equation, something like that. Sub functions are listed below the primary function. They are only accessible by the main function and within the same M file, and not by the command window or any other function or scripts. That's true. Any variable that will be created will only be accessible inside the main function, and then the variable in the sub function will remain there. It will never be used in the main function if you don't echo it, you don't return it. So that's a sub function. So let's have an example here, by the way, before we proceed. Okay, what do we mean by that one? So this my function, I want to decompose this one into two functions. It would be easy to do that. Let us do this. This pi times radius, I will put it into another function. Okay, so let's say let's do like this. Area circle is equal to compute area. This is the name of my sub function, by the way, and then I will input radius. Okay, and then here I will name again function A is equal to compute area, and then B. Okay, A is equal to pi times B squared, then N. Okay, let's do this. Sorry, this is wrong spelling. Okay, so what does it mean here? My function radius, whatever that will be echoed from the command window, it will go here, and then the area circle is equal to the compute area. You are invoking a new function or a sub function named compute area, and then you are passing the argument radius in that compute area. So what is compute area? It's here, function A, the output argument, and then you call compute area, and then you just write here B. So this B will carry the variable radius. It will be inputted here in B, and then you compute A is equal to pi times B squared here. So A will be returned, and then A will be equal to area circle, and then that's it. Actually, this function it will just do the same thing in the function a while ago, but this is a sub function. This one is a sub function, and this is the main function. Okay, so it's not yet saved again, and then when you click here, it's saved. So let's call it again. Let's say car is equal to my function radius, let's say 3, equal 3 again. So this time the function, my function, it will do the same thing, but different way. So when you hit enter, car is equal to 28.2743, and it's just something the same. Okay, that is sub function. Input. So sometimes you want the user you want to prompt something, a string, and then the user will write or input something based from what you wanted him to or her to do. So the easiest way to get a value from the user is using the input command, meaning here that to make it more interactive, the user will your function or your script file will ask something from the user. So you say please input an integer, input a string, input whatever. So here n is equal to input and then prompt string. So what it will do is it depends on the what you wanted for him to input, but most of the time it could be integer. And if you put there an s, something like that, apostrophe and then s, it will display as a string. So if you type pi n, it will store the letters p and pi in a 2 by 1 char array. But if you don't put that apostrophe s, then close no, it's not parenthesis, apostrophe, then it will treat pi as an integer. Okay. So what I'm saying here is, let's just make a simple example here, so that you will not be confused. Let's go back to Michael.m, okay, the one that we started a while ago. Now we will make here, we will input here, let's say b is equal to input, let's say input an integer, okay, like that. So I put here a space so that later when it pops up, there will be a space for this one. So anyway, you will see the user will write somewhere here. So b is equal to input an integer. So b is not equal to this one. Let's just put this, so letter C, and then this one, just make it b, and then let's echo the letter C also. Okay. So b is equal to input an integer, meaning to say letter C will depending on the value of b, but a will be always constant. Okay, let's click here, and then let's say Michael. Okay, when you hit enter, says input an integer. So if you write 10 here, so let's write 10, hit OK, and that is correct. So if a is 4, is b is 10, then a plus b is simply 14. I mean 4 plus b, I'm sorry, 4 plus b is simply 14. So it's just like that. So you input the integer based from this one. So the function there is input. Okay. Now the output, if you want to pop up something like hello, how are you, something like that, what is the proper function for that? So we will see. The easiest way to display the value of matrix is to type its name, but that will not work in function or script files actually. Instead, we will use the disp command, this short for display. So that is the command, this, then value, it will show the value on the screen. If it is a string, you put some parentheses, I will show you now. And if it is integer, so you just write immediately the variable. So how do we do that? Okay, it's here. So let's go back here in our workspace. B is equal to input an integer, b 4 plus b. Now this one, let's write here this, and then hello everyone, let's say hello everyone, like that, and display how are you, okay, how are you. So we put here a single quote, this one and that one, because this is a string. String is like a word, it's like you want to print that one as exactly as how we wrote it there. And then you want to echo this A, B, and C, but do not write like this because this is a bad actually programming style. It's not good. You write this and then you enclose it like that, and then put a semicolon to end it properly. It's not A, B, and C. It's not good. Okay, here, and then this A, B, and C. So I think you know what will happen here. So let's move on to the command window. Let's call Michael, hit enter, and input an integer, let's say 20. Okay, so it says here, hello everyone, how are you? And then display A is 4, and then B is 20, and then C again is 4 plus 20, and that's 24. So, okay. Next is formatted output. Somewhat this is much better, but it will become complicated as we move on. If you are programming a lot of things, sometimes this is not so good, but just be careful here. But it will still be easy. Okay. So formatted output, what does it mean? I will show you. So for formatted output, or for output generated by combining variable values with literal text, means say the number of pencils are, and then 4 is in a certain variable. You combine text and the integer. How do you do that? So you will use this one. The format is like this: f print f, and then a single quote format xy, and then there are several formats here. It is a string, but the value of the variables x and y are to be displayed if you want to be float, decimal. So what I'm saying is something like this. Control codes, I think somewhere here. If you put it %d, that is your format, then it is an integer format, scientific format, E and capital E, F, G. And then the following control codes produce special results within the format string. If you put /n, it will start a new line, /t tab, print the character, something like that. Alright, I will show you an example so that you will understand. But by the way, I will explain this first. Look at this one. Display hello everyone, and then after that it says how are you. Here, hello everyone, and then there is it goes to a next line, and then it wrote how are you, and then 4, and then again B and 24, something like that. There is a next line here, but in how do we do it in f print f? Okay, we will do that. Okay, let's say what shall we do? Let's say we will make something like this. Let me change this one first. Okay, instead of that one, we will say f print f. Let's say hello everyone. Okay, and then let's say here f print f. Let's change this for a little bit. Sorry, f print f. Then say I have %d sorry, the format %d, then apples. Okay, and then you put here like this, and then say %d, let's say I will call C. Okay, the value of C. So hello everyone, f print f, I have %d. I'm referring to the first variable C in a decimal format or integer format. So the value of C here is I think it's 24. Yeah, so we should expect I have 24 apples. Okay, we will try to do that here. Michael, input an integer, so let's say let's change it a little bit, 10. Okay, hello everyone, you see this one, hello everyone, no line, no next line, immediately I have 14 apples. And then since there is no new line here, display A is written here, and then after B and C is in the next line. So if you want to repair this one because you don't like it, hello everyone, and then immediately I have this %d, the format of C, that's 14. Okay, 14 apples, that's correct. So if you want to repair that one, you put /n here, /n, and then here /n. Let's see what will happen. Michael, and then say 10. Alright, here we have this one. my hello, input an integer 10, hello everyone, and then slash n, next line, I have the percent %d, so this is actually like C or C++. C++ is just C out, and then in C is something like this, printf. Percent %d, so 14 apple, so for C, and then everything will be just the same. Okay, so just like that. What is this? To print, put a pair of in the format string. Sometimes we will double it. If you want to put a quote, you have to double quote it. We will do that as we move on. I will show you. Okay. So creating and accessing files, it's not so important in this course. So we will just leave this for now. It might be, it might confuse you. We can call a file name like .mat or text files, and then the MATLAB will make that, or even Excel file, you call that one, and then the MATLAB will use it as an input. He will understand the things inside of that Excel file, and then put it in the program, but we will not do that here, so let's just proceed here. Okay, so ASCII files, save command, that text or that. Okay, let's just move. Okay, we don't need this. Structured programming. What does it mean? Okay, the structured programming allows MATLAB to make decisions or selections based on conditions of the program. Decisions in MATLAB are based on the result of logical and relational operations and are implemented with if else, and if structures. Okay, and selections in MATLAB are based on comparisons with a test expression and are implemented with switch structures. We will talk first with if else. We'll try to do that. I think you have tried that before also in your previous programming language if you learn C, C++. Or if not, then okay, you can follow me. It's not that difficult. So let's try to this program. We will try to add some things here. Okay. So let me do like this. Hello. Here. Let's put an if else. If b is less than 10, let's indent that. Then I'll say, hello, how are you? How are you? Okay. Then else if b greater than 10, then I'll say the number I have, no, it's better. Okay, so we have to use, I have apples, like that. Then let's say, we'll just use A here. Or which one's better? Okay, C, probably. This is just an example. Then else, printf, my quiz score percentage is percent f, then slash n. I forgot to put this slash n here. How are you? Okay, for the meantime, let's do that. And then let's erase this. Or if you want to see that one, no problem. We can just put it there. Okay, this is n. Okay, I think this is fine. Slash n. Then put here b. Sorry, here. B. Okay. So my quiz score percentage is whatever is b. So this is the condition. If, else, depending on the value of b. If b is less than 10, greater than 10, or not, then you can do that. Okay. So let's try to write something here. display A, B, and C. Okay, this is just fine. Okay, let me execute something here. Okay, let's write this one. I mean, run Michael. So let's start with B is equal to 5. Okay, I'll write 5. Okay, so you see this one? 5, B, since B is less than 10, it write this one. Hello, how are you? But no slash n, remember? So these two statements are not implemented. Only this one, because this is true. And hello, how are you? Here. 5 and then 4 is immediately here because display A, this displays the value of A, which is 4. But since there is no slash n here, so that is 4 and 5 and 9. Okay. Again, let's do it again. Michael, let's say 15. So we should expect that it will write, okay, here 15, and then it says here, this is true. I have C, so 15 plus 4, 14. So I have 15 plus 4, 19. I have 19 apples. Okay, and then display A, B, and C. Okay, and lastly, if you want to try Michael, let's say 30. So else actually is 30 is greater than 10, so it's still the same. I have 34 apples. It's still, this is true. But what is this else? Else means when B is equal to 10. So let's write Michael, and then 10, enter. So it wrote this one. My quiz score percentage is 10%, for example. Okay, by the way, how do we write percent here? We will try to do like this. Double the percent. Sorry, here, because MATLAB will be confused. Double percent. Okay, let's do it again. Up arrow, Michael, then 10. So my quiz score percentage is 10%. You have to double this one. Okay, if it's only single, MATLAB will be confused. He will ask you to write F or D or E or something like that to make a format. He will be confused. It will be confused, and there will be a problem. So if you want just to put the percentage, you do like that. If you put a double quote, single quote, you put double here. Something like that. Okay, put a single quote, and then let's do it again. Michael, and then say 10. So my quiz score percentage, you have to double it, because MATLAB will be confused. One single quote here, another here, so it will be confused. So you have to double it, and the effect is this one. Okay, I hope you understand. Relational operators. I think we already tried that one. B less than 10, greater than 10. So these are the things. X is equal to 0. Remember, double 0, not only 1 equal to 0, not x is equal to 0, because if you write x is equal to 0, you assign variable x to 0. But if you put x and then double equals 0, it means that you are testing whether x is equal to 0. So the output here is is only 1 or 0. Okay, so a is equal to 0, s is equal to greater than t. So this is just a relational operator. Okay, this is a boolean actually. Boolean means it will just give you either 1, which is true, and 0, which is false. Logical operators, what are this? Some of this you learned this in mathematics. With that bar there, not x, actually that's shift this before left on the one character here, shift of that. We have this 1, 2, 3 in the numeric character, so shift of that left character of 1, that is not x. Okay, and then what else? X and y, so x and y, that's what I'm saying, and then x or y, if either x or y are true. So okay, we will try to do this relational operators first, so that you will understand. Let's go back a little bit. Okay, so let me just write here in my let's say a is equal to 4 in the command window, and then I will say a less than 0. So of course that is false, so the answer is 0. Okay, answer is equal to, meant to say boolean, variable, so ans is boolean here, it's give us 0. Now you will say a greater than 0, that is true, it will give you ans equal to 1. Okay, so b is equal to 2. Okay, and then you say b is it equal to a? You're asking, is it b equal to a? A is equal to 4, so of course this is 0. No, it's not. B less than pi, is it true? Yes, it's true. A less than pi, that is also false. And lastly, a greater than pi, that is true. Something like that. That is relational operator. So logical operators, I already told you a while ago. We will make some examples here. In our still in our function here, Michael, let's just add more. So we will say here, we will use this display something. Let's hello everyone. Hello everyone. Okay, let's just write a lot of things. Just remember this one. This is just easy if you just practice. Okay, how are you? Quotes. Okay, then display A, display B. Okay, we can do that. I will put it somewhere here. Okay, let's just change the order of the operation, and then we are using this operation. So let's say if B is less than 10, and let's say C is less than 10. So no, this is wrong. This is an. Where is an? C less than 10. Okay. If B is less than 10 and C is less than 10, remember the AND logical operator. If true and true, it's true. But if one of them is false, then everything will be false. So we will write this one. Okay. Else if B less than 10, let's just put that, and then this like that here in the character, somewhere near the enter, and then C less than 10. Okay, C less than 10, F print F. We have this one, so we know that OR, if one of them is true, then everything will be true. True or true, true. True or false, true. False or true, true, and then false or false. That's the time it is false. Okay, and lastly, else, we will put this one here in the end. Okay, so we will see for what will happen here. Let me do this one. Okay, so Michael, let me call Michael. Okay. Input an integer, so let's say 6 first. Okay, so what will happen? B less than 10, it's true, and C here is 4 plus 6, 10. So C is 10. C is less than 10, that is false. So this one is false, so it will not be executed. B greater than 10, that's false. C less than 10, that is also false. It will not be executed. So we should expect that this statement will be executed. We will see. Alright. It says here, hello everyone, how are you? This one came from here, and then A, B, or C for 6 and 10. My quiz score percentage is 6%, something like that. It executes this one because these two are false. Okay, let's do it again, Michael. Let's say 20. 20, B less than 10, no, wrong. B greater than 10, true. Or C less than 10, C is 24. Well, that is false, but since this is true, I know, this is really, it should not, I'm sure this will be executed. So let's do like that. I have 24 apples. Okay, So this one is true, this one is true, this one is false, so that's why. Okay, hope it's clear. Order of operations, we just simply read this one, which one is a priority, multiplication, and everything. The not is the highest priority logical operator, followed by and finally or. Okay, just remember this, and then some of these rules here. Okay, let's proceed. Decisions. So decisions are made in MATLAB using if structures, which may also include several else if branches and possibly catch all else. But actually, we tried this already. So okay, just try to read this one, and then we'll just skip this one. We already do this one actually. Selections. Okay, selections are made in MATLAB using switch structures, which may also include a catch-all otherwise choice. Okay, we will make an example here. Deciding which branch runs is based on comparing the value in some test expression with values attached to different cases. If the test expression matches the value attached to a case, that case branch will run. If no cases match and there is another otherwise statement, that branch will run. We will try to do that. Okay, so let us have an example here. It's still in this example, but I will write here be input an integer from 1 to 3 only, like that, and then everything will be the same, but I will write here test. I will erase all of this actually. I'll erase that, and then I will say test is equal to b. Okay, and then switch test. So depending on the value that will be inputted by the user, it could be 1, 2, and 3. So it will this one will do something. So if test is equal to 1 or 2 or 3, it will do something. Oh, I erased it a while ago, unfortunately. Anyway, so let's say case let's say 1. So if b is 1, f printf. Oh, sorry. Control Z. F printf. What? Hello. How are you? How are you? Okay, we will put /n here, right? So case 2, printf. I have %d apples. Okay, this is C. I'm sorry, let's put that semicolon, and then case 3. I mean to say this is the value of B. Remember, we will ask the user to input that one depending on his input. The quiz score percentage is, let's say, %f /n. I forgot n here. Let me write /n here also, /n, and then like this, let's say b. Okay, and then you can also write here otherwise, okay, according there, otherwise, and then you say f printf, you did not follow the instruction. Okay, so we are angry here. You did not follow the instruction. Okay. And for the switch, okay. So if the user will input 1, 2, and 3, there will be some corresponding statements. Other than that, it will say otherwise you are not okay, or you are not, it's better to say you are not following instruction. Okay, so let's do this. Let's hit Michael again. Input an integer from 1 to 3. So I say 1. So hello, how are you? Okay, again Michael. 2, I have 6 apples. Okay. Again, Michael, 3. The quiz score percentage is 3%. Okay. And then lastly, Michael, say 100. You are not following instruction. That's good. I hope you understand that one. It's a very, easy explanation here. Okay. So that's how switch function or structure works. Loops, you learned this before in your programming languages. This is a very basic structure in programming. So I think you already knew what are the types of loop in a program. Another programming structure involves loops, where the same lines of code are run several times, and there are 2 types of loop. A for loop ends after a specified number of repetitions established by the number of columns given to an index variable. And also we have a while loop. Okay, we cannot read it. Ends on the basis of a logical condition. So a for loop will repeat itself until such time that the specified number of repetitions are met. But a while loop will repeat infinitely until that logical condition is true. If it is false, then it will escape. Okay, so for loop, what is this? Okay, this is the format syntax. For index is equal to start, step, finish, statements, and then end. Okay, so for m is equal to index variable. It could be anything, but my warning is do not use I and j. Although we can use it, it's just fine. But you remember, I and j. This is for they are reserved for complex variables, so better do not use that one. Okay, so let's do this in the for loop. Let's erase this one. Maybe you can erase this. Okay, this one will remain the same. We'll write here for m is equal to 1 to b. Whatever the executed value of b there, then f.f, say hello, how are you? This statement keep on repeating, and then you put n here. Okay. Another thing, for m is equal to 1 to b. Let's say f.f, the number of apples, or I have, it's better to say I have %d apples. C. Then put n here. What is m? So let's put here m. M is equal to, let's say, 0. Okay. So what does it do? M is equal to 0. For m is equal to 1 to b, depending on the value here, let's make it 5 here. So if the user will input 5, so m will repeat from 1 to 5. It will repeat the statement, and then after that it will escape the statement, and it will go here. Okay, we will see that one. So Michael, let's say 4. Alright, we have a problem here. Why? 4, so A is 4, B is 4, then C is 8. We don't need it. M is 0, so it prints hello, how are you? Okay, and then after that M becomes 1, hello, how are you? Again, M equal to 2, hello, how are you? Then M equal to 3, hello, how are you? Okay, so by the way, no, M is equal to 1 because this is for M equal to 1 to B. Hello, how are you? Okay, so actually we can just erase this M equal to 0 here. It's not needed. This is for the while loop. Okay, no problem. So hello, how are you? Hello, how are you? M is equal to 1, M equal to 2, M equal to 3. Okay, to make it easy to track, let's put here display M, and let's do it again. Okay, M, and then let's put here a space. So that slash n for next line. Let's run it again because this one is not good. So we have to put here the command because there's no next. That's not return carriage return, which is a line. Michael. So input an integer from 1 to 5 only. Let's say I want 3. Okay. So 3. Hello, how are you? M is equal to 1. Hello, how are you? M equal to 2. Hello, how are you? M is equal to 3. And then when M is equal to 3, remember, it escapes this loop, and then M returns to M is erased, and then it become 1 again. Okay, remember that M is only available in this for loop, and then it's erased. Then it uses one. I have 7 apples. M equal to 1. I have 7 apples. M equal to 2, and then I have 7 apples. M equal to 3, and then N. Okay, so that's what happened here. Okay, so that is a for loop. Depending on how many times you want to repeat the statements. Hello, how are you? Based on this M equal to 1 to B, something like that. Okay, so vectorization, you can see this one. This is just quite simple using this colon operator. So if you look at the for loop, sometimes we will use this most of the time. In the left side, as you can see, the variable t is assigned from 0 to 0.02 to 50, and then I is repeated starting from 0, and then he is making a function cosine t 1 by 1, but it's better to use it immediately. Vectorization, you have t, and then you call y cosine t, like what we did before in making a plot. So immediately you have the function. That's vectorization. No need to make cosine t 1 by 1. Okay. So anyway, this is not so much important, but take note of that vectorization. Instead of using a for loop, we can use it in a very concise way by using that vectorization. While loops, what are these loops? Okay, so a while ago it needs a condition. So the general syntax is that one, while condition statements n. Okay, where the condition is a logical expression. If the condition is true, you will run the statements indefinitely. If it is false, then you know, of course the loop will again check the condition, and then if it is false, it will escape the loop. Note though the condition may become false as the statement are running. The only time it matters is after all the statements have run. Yeah. So once it is false, it will still continue all the statements, and in the next loop it will escape. That's what I'm saying. So a simple example here, we can erase this one again. Then let's write here. Let's say while m is less than b, for instance, f print f. Hello, how are you? This time we will put slash n like that, and then m is equal to m plus 1. Okay, I will explain this, and then this is n. Here we will initialize m equal to 0. It's needed. And then while m is less than b, when you input here a value, say 3, b is equal to 3, so it will perform the statements. But remember, we have this one, we call it a counter. As it make the loop, m will less than b, of course this is 0, and then m will be m is equal to m plus 1, meaning to say m is equal to 0 plus 1, m will become 1, and then 1 is less than 3, okay, like that. So we will see. Michael, let's say 3. Okay, so 0 less than b, true. So print hello, how are you? Okay, and then after that m is equal to m plus 1, so m becomes 1, and then it checks 1 less than 3, it's true. Print again hello, how are you? And then 1 plus 1, m equal to 2, and then repeat 2 less than b, that is true. So hello, how are you? Print hello, how are you? And then m is equal to 2 plus 1, m is equal to 3. Here 3 less than 3, no. So it's false anymore, and then it escapes, and then that's why. No more repetition of the statements. That is a while loop. This is just a basic um, basic explanation of this, but this is just quite fine. In our program, in our application, in the numerical methods, it will become more not so very complicated, but we will follow a pseudocode, and there are some built-in functions also that we can use. But this is the basic understanding of any in our course. Once you understand the for loop, the while loop, how does it work, how to do it, how to to make this as if what we want it to behave in our program, then everything will be much fine. Okay, just practice this. Okay, so early termination, what does it mean here? Okay, I will show you. What if I will say that you don't want the while loop to continue, you just wanted to erase it somewhere after a certain loop, after it will occur at some time. So it will be useful to break out of a for or while loop early if you want that one. This can be done using a break statement, generally in conjunction with an if structure. Okay. So example will be just something like this. Okay. We will make ourselves here, we will just continue with our function. So, okay, let me write this one. So, while 1 there, as you can see, while and then 1 is true. Meaning to say the condition is 1, so, well, it's always true. Meaning to say, if you invoke while 1, meaning to say that you are invoking an infinite loop, because the condition will never become false. So, if you want to escape in the loop after some time, you need to put a break statement. So let me write here, let me change this one, while 1 for instance. Okay, and then f, hello, how are you? And then let's put here, if m is greater than b. Okay, if m is greater than b, we put here break. Okay, and then n, of course we will end the if statement. Remember, let's put here display. We can also write here f, and f, the value of m is %d m. Alright, so to monitor the value of b, I mean m, you can do that. So are you excited now? What will be the output here? Okay, we will see. Michael, okay. 1 to 5 only. Okay, let's hit 4. Okay. Oh, I forgot to put some /n here. Okay, let's do it again. 4. Okay, here. Okay, printed this one. Input is 4. Hello everyone, how are you? It starts from here. Display A, B, and C. So these are the value A, B, and C. Hello, how are you? So if m, remember m is still 0 here, so this thing will never be executed. Okay, so hello, how are you? The value of m is 0, so this one, this is statement, and then m is equal to m plus 1, so m will become 1. It will repeat the loop. So hello, how are you? The value of m is equal to 1, and then again, hello, how are you? The value of m is 2, and then hello, how are you? The value of m is 3, and then hello, how are you? Value of m is 4. This is quite boring actually, but anyway. And then when m is 4, when it returns back, remember this is a while loop, this is infinite loop. It will never stop, remember that. But when m is equal to 4, if m is greater than b, break. So when m is 4 here, somewhere here, this is statement, m is equal to 5 here, m is equal to m plus 1 will become 5, and then when it repeat the loop, 5 is greater than 4, that is true, and then you break, so you get out in the loop. Okay, you can even put statements here. I can say display goodbye, like that, so that you will see. Okay, let's run it again. Then it's use 4. No, it's break. No, I'm sorry. So the display is not echoed because the break occurred first before that display command. So let's do it again. Michael, then 4, so here. Hello, how are you? The last hello, how are you? And then when you check here, m is equal to 5, 5 greater than 4, then display goodbye, and then break. So that's it. Okay. So that's the importance of a break command. Animation, not so very important in our applications here. I just want you to read this one if you want to try. Of course, animation is really looping, okay, but the looping is just a little bit fast. That's why in our eyes it seems like there is an animation, just like looking in a cartoon movies, like they are all animations, Pixar, Disney, and these are series of still image, and then our eyes cannot capture the very fast transition of these images. That's why we saw it as a movie. So somewhere here it's still the same. We have this function get frame and movie. I don't want to elaborate this one. You can just read this and practice it. But there's an example here. This function, I think you remember this function. It seems like it's a projectile motion, yeah. So just look at that one, and then there's a velocity, angle, and everything. We will try to animate that one. There is a simple script here. Okay, this is not a function, but it's a script. I will copy the script, and then okay, or we can do that. Okay, so to do that, I will escape here somewhere here. Okay, for a while, and then okay. Here, I will make another script. It's untitled. Okay, I will just paste that one. Right click and then paste. This is the script, and then I will save this one. Save as. I will just make a name. Okay, it pops up this one. I will just say sample animation. Then hit save. Okay, you can click run here. By the way, it's somewhere here now. Sample animation. You can click run here. Okay, it's in the current folder. Click run, or you can call sample animation. So when you run this one, what will happen is something like this. You will see. By the way, I will explain somewhere here. This one is the animation somewhere here. This for loop here. I want to explain all of this, and then it will pause. So it will ask you to hit a key, whatever key here, and then it will repeat the animation. It's in movie M1. M1 is this get frame, so you repeat the movie again. So let's do that. Let's run it. Okay, that's the animation, as you can see. Projectile motion. All right. As you see this one, pause, press any key. When you press this one, it will animate again for the second time. And then as you can see here, this is busy here. So it's animating. Okay? And then after that, it's finished. Okay. So here, you can now write the program again. So if you want to do it again, you can repeat it. Hit run. And then here, busy. Okay, it's animating. Yeah, but this really it's just really a for loop actually. And then changing the coordinates, and then it's press, you hit another some key here, and then it's pause, I'm sorry, and then another animation. Okay, it's done. Right, it's great. Okay, so you can practice that, but it's not important in our course. Okay, result. Yeah, this is what the result a while ago. Nesting and indentation. Okay, this is also very important. I will this is somewhat similar to if else, but you will put a lot of statements. We will see. Structures can be placed within other structures. For example, the statements portion of a for loop can be comprised of an if-else structure. Okay. And for clarity of reading, the statements of a structure are generally indented to show which lines of control are under the control of which structure. What does it mean? We'll give you an example here. Let's go back to Michael.m here, and then let's make this to 10. Then I think we already have a while loop here, so let's just add some things here. If m is, let's say, less than b, let's say, okay, if m is less than b, and let's nest it, we'll put another statement. If m is less than a, this is what the program means. F print f, I'm fine. Okay, so f print f, I'm fine. Okay, the double quote here will give us one single quote in the final, in the display. I'm fine, and then okay, let's erase this one, and then let's put here else. We need to say if m is greater than or equal to a, else f print f. Let's say, oh, I'm sorry, I'm not fine. I'm not fine. Okay. Let's put /n. I always forget this one. Then if m is less than b, by the way, let's put n here. Okay. If else, put n. If m is less than b, n. Else, let's put else here. Else, f, print f, print f. Say goodbye. /n. Okay, and then break. Then f print f. Okay, m. Okay, let's try this one. M less than b, m less than a. So let's try, say, Michael. Let's say 5. Okay. So B is 5, C is 9. Hello, how are you? So it prints hello, how are you? And it says I'm fine. Hello, how are you? So the first one, I'm fine. /n. Oh, no need for /n because this is display. I'm sorry. Anyway, it prints that one. I'm fine. The value of m is 0. Okay. Again, repeat the loop. Hello, how are you? I'm fine. The value of m is 1 because of this one here. Hello, how are you? The value of m is 2. Hello, how are you? Value of m is 3 until hello, how are you? The value of m is 3. Okay. Value of m is 3. Remember, b is equal to 4. We input that somewhere. No, b is 5. Okay. So when b is equal to 5, so it says here, if m is less than b, which is true, m is equal to 4, 4 is less than 5, but m is less than a, if m is less than a, 4 is less than a is 4, which is, this is false now. It will never execute I'm fine. Rather, m is greater, equal to a, so that's why it will execute I'm not fine here. And then the value of m is 4 already. Okay, and then lastly, when it go back to the while loop, m is equal to 4. When it repeats, when m is equal to 5, 5 is less than 5. No, that is not true. That is false. So it will execute this one, and it will print goodbye. So hello, how are you first here, and then these things will never be executed. It will go here immediately, else, and then you say goodbye. That's it. That's the output. So this part here, this is what we call nested if else statement. Okay. 2 more slides. Anonymous and inline functions. Okay, we will try to do what are these things. Inline functions are not anymore common in MATLAB. We will not use that one anymore, but rather we will use anonymous functions. And this is the expression f handle is equal to at, and then argument 1, argument 2, and then expression. Meaning to say, we can make a function just in the command window, and then we will input some values there. We will try to do that. Anonymous functions can access the values of variables in the workspace upon creation, while inlines cannot. But I will really, let's use anonymous functions because it's far more better. So let's try to clear the screen here. Yeah, clear, and then CLC. Okay. So let's say F1, this is the handle, is equal to at, then XY, I'm sorry, XY, and then my function is x squared plus y squared. I think you will understand, then we will put the semicolon. So it creates in the workspace a function equal to x squared plus y squared, and then the input is x and y. You will put at there. So let's say if you call here F1 and then you put 3, 4. So it will give you 3 squared, 9 plus 4 squared, 16. So this one will give you, that's 25. Okay. Or you can put that in a certain variable. Say b is equal to F1, 3, 4, 3, 4. Call that one, and b is equal to 25. That's it. If you call here something like function F2, let's define first a value. Say a is equal to 3, and then b is equal to 2, b is equal to 2, right? And then F2 is equal to at xy, but this time we will put a times, remember a is equal to 3, a times x squared plus b times y squared, like that. And then if you call that one, let's say c is equal to F2, let's say 3, 4, then here we go, it will become 50. Meaning to say x squared, what is that, 3 squared, 9 times 3, 27, and then this one 16, 4 squared, 16 times 2, 32, 27 times plus 32, that's really 59. Okay, that's it. So that's what I'm saying. You can make a function in the command window. Okay, and the last important which we will do is what we call functions. We will input function in the command window, and then we will send it in the function file. Okay, functions are functions that operate on other functions which are passed to it as input arguments. So the input argument may be the handle of an anonymous or inline function, the name of a built-in function, or the name of an mfile function. So in our function, you remember we will input some arguments there. We can also input a function which we will define in the command window. Okay. So using functions will allow for more dynamic programming. So what I'm saying is something like this. Let me write in the command window, let's say clear screen. Okay, let's use this my function. Okay, instead of this radius, let's make it much more dynamic. Let's put here func. Okay, so we have here two arguments, func and radius, and then this one we will by the way I will erase this one. Okay, we'll erase that sub function. Rather, I don't need the sub function inside this function. So many functions. Rather, I will define the function in the command window here, and then I will send the function in this function. Okay, but the output will be the same. So instead of compute area, I will put here func. Okay, radius. Okay, so my input now in this function are function and radius. So I will build the function here. Remember that the function will create the area. So simply I will just write f3 is equal to at let's say r, because r is my variable, and then my function is pi times r squared. At r, that is your independent variable, just think of it something like that, and then pi r squared. Okay, so you put this at pi r squared. Now if I will call this my function, I will say Mike, so I will store the area of the circle to Mike is equal to my function But instead of radius a while ago, we have two functions here, f3, I mean two arguments f3, and my radius say 3. Remember the answer a while ago? The answer is around pi r squared. 9 times pi 3 is around 28 something. So what does it mean here? f3 is passed into the my function here, in this func here. So f3 is an anonymous function, and then 3 is treated as the radius. So after that, it goes to this second line, the first statement of the function. It calls the function func and input the radius, of course, which is r for the f3. Only one input here. So when we enter here, of course, mic will be equal to 28.2743, just like what we computed before. I hope you understand this one. We will practice this more in our laboratory exercise. And I hope you understand. And with that, thank you.